Well, folks, once again, welcome back to my basement boatyard. Captain Boat Builder here. Today, episode number 18. I'm calling this one Things to Know About the Mast. Once again, this is the line drawing of the Viola 14, and I look at it from time to time just to give me some encouragement. I've also been able to take some measurements and some angles, even off this small drawing, to help me get the mast straight, especially with the rake, the fore and aft rake, and the general position of the mast. So today, I'll be showing you the system that I came up with for getting the mast in the correct position and finalizing the construction of the mast and putting the sections together so that the mast can be taken apart. It's now a nice two-piece section. So once again, episode 18. In this section of the video, I'll be talking about what I've done to try and be certain that the mast is in the correct position. And by that, I mean I want it to be in the correct position relative to port and starboard so that it's completely vertical. And I also want it to be in the correct position relative to forward and aft so that the rake is correct. But I do have to start by making yet another correction, and this has to do with terminology. In the past, you may have heard me refer to this part of the boat right here as a thwart. And in fact, it's not a thwart. As it says in the directions, it's called the partner beam. For some reason, I thought it was also called a thwart, but it isn't. And so I stand corrected. I looked it up, and a thwart is actually a plank. And here's an example. In an open dinghy that's either temporary, as this one could be, or permanent. And it's designed as a place to sit when you're rowing or paddling. And for purposes of demonstration, the little temporary thwart that I have positioned, you'll notice, also has a drink holder, which is very important. But anyhow, I stand corrected. And so in the past, when I may have referred to this as the thwart, it's not the thwart. So back to getting the mast in the correct position. The starting point for reference, for me has been the floor. The floor of my basement is poured concrete. I've checked it with a level in many places, and it is surprisingly level. That's been my reference point. The boat is secured to the short sawhorses. It's held in place with Gorilla Tape, which is remarkably strong, and it's quite easy to adjust. So it was quite easy to get the boat to sit on its lines level from side to side, just using a level at different points from the left side to the right side, reading the bubble, and sure enough, got the boat level. What was a little bit more difficult was to figure out how the boat was supposed to sit on its lines in the fore and aft axis, bow up, bow down. And part of the reason for that is that the hull has quite a bit of rocker all the way from the front to the back. The bottom of the boat is not flat, it's curved, it's up at both ends. And so it made it just a little bit difficult to figure out, well, when is it in the correct position? Fortunately, Michael Stora, the designer, came through again and helped me out a lot. If you look at the line diagram here, again, this is the boat sitting on its lines. And you can see right here, this line, this horizontal line, that's the water line. So the question is, from the water line up to the bow and from the water line up to the top of the transom, those two measurements help determine when the boat is in fact sitting on its lines. And what Michael was able to supply me with is this dimension here, this distance, relative to this distance. And it turns out that the tip of the bow sits 49 millimeters higher than the transom. So all you have to do is measure from the tip of the bow down to the floor. You measure from the center of the top of the transom right here down to the floor, and you just make certain that the bow is 49 millimeters higher, and then in fact the boat is sitting on its lines. So that's where I have it now. As far as the alignment of the mast, I've used a string and a plumb bob hanging from the ceiling, and this 5-foot section is just my practice mast. And if you look carefully, I think you can tell that the distance between the string and the mast at the top and the bottom is about as close to equal as I can get it. So now we know that the mast is parallel to the string is vertical, that means the mast is vertical. Then you can also use the string to determine the mast rake. And here you can see that down near the bottom, the string is relatively close to the mast. And as you go up, you can see the separation. So the mast is leaning aft from the vertical. And with this 5-foot section, you can sort of extrapolate. You can measure this distance here, separation between the mast and the string. You can change it by a factor of 3 approximately, and then you'll know what it would be at the top. And you can adjust the rake that way. So this string actually helps you on both axes. The point that I wanted to make in closing is that all of this is done because I'm certain that all of the pieces that I put together, since they're wood, none of them were cut exactly. And as I assembled the boat, I'm sure that some of the pieces were slightly out of position. You have an error of a 1/16 of an inch here or there. You add it all up and pretty soon you've got a more significant error. So what I wanted to be certain of, once I got the mast straight, I wanted to be certain of the position of the base of the mast on this piece of wood right here, because this isn't glued down yet. This is what's going to have the hole in it. I'm going to be cutting the hole right about there. So the mast will slide through this and it will actually come to rest on the bottom piece, which is secured to the hull. But the position of the hole is critical, because if you imagine this hole right here in the partner beam as the fixed point, as the pivot, you can see easily that if you move the base just a little bit, maybe a 1/16 of an inch, you're going to get quite a bit of movement at the top of the mast, 15 feet up toward the sky. So that placement is critical, and I'm going to be measuring and checking and checking and checking and doing it over and over again. But that's the way I've determined the correct position for the mast. I hope this helps you. If there's an easier way, I haven't been able to figure it out. Well, except for maybe some painting. I finished the fiberglass work on the upper mast. This is the lower part of the upper mast. This is the smaller diameter mast, of course. This is the lower part that fits into the larger diameter lower mast. This buildup here and here has been done with many, many layers of fiberglass tape and epoxy wound carefully so that we get a nice smooth diameter, and a lot of sanding to make sure that the fit is good. This little piece right here is the collar, and the collar is going to fit right at the top of this upper section of fiberglass expansion. The dimension from here to the base is 30 millimeters, and that's specified in the plan. That's what they refer to as the bury, B-U-R-Y, and that's how far the upper mast is essentially buried into the lower mast. This sleeve at the top is being held in place with 4 sheet metal screws. These go all the way through. These are going to be bedded in epoxy, and this sleeve is going to be coated on the inside, and the fiberglass is going to be coated with epoxy so that this whole unit is glued together. And this limits the amount to the correct dimension for the upper mast to be buried, as they say, into the lower mast. This does not have, my understanding is it does not have much compression load on it because this is an unstayed rig. If we had stays, a head stay and some shrouds, the compression loads would be much higher. But this is just to position the upper mast inside the lower mast, and these build-up areas distribute the stress, make sure it's a nice snug fit, and it takes care of any wiggling and handles the bending loads. And this is what the assembled sections are going to look like, of course minus the screws. This is the lower section, the bigger pipe. It's going right up to here, to the sleeve where it will stop. The upper section of the mast is buried in here, 30 millimeters. And I'll be putting some epoxy here and doing some grinding to make a nice smooth transition from the smaller pipe to the bigger pipe. And that's so that when I slide the sail up and down on the mast, it'll slide easily and without chafe. But this is how the mast is going to go together, how you get the two pieces to connect. And it's not really very complicated. It just took quite a bit of time and patience to get the fit just right. You can see that it's a nice tight fit, almost no wiggling. And I'm pleased with it. It just took, as everything else, it took a lot of time. Just a few shots here now as I'm finishing up the mast. You'll notice up here at the top, I've got a section that's a step down again. This is also buried in this mast section, similar to the way it was buried down at the bottom with the fiberglass. This is all glassed in place, very solid. And what I was trying to do is I had quite a bit of trouble sourcing the right size aluminum tubes for the mast. Had a problem with the thickness, the wall thickness and diameters, and in the beginning I ordered sections that are probably a little bit too heavy. And to try and mitigate that problem, I shortened the bottom section right here. This is the biggest section. I shortened this piece, made it up on the top with a smaller section, and I'm hoping to balance it out that way. Down here again, you can see where I've got the fiberglass tape wrapped around so that this part is actually buried in the top part of the lower section. And if you were paying attention and you weren't taking a nap, you may notice that earlier I talked about the bury being 30 millimeters. Well, I was only off by a factor of 10. It's 300 millimeters. So if you're paying attention, you could see that 30 millimeters was just way, way too short. It's 300 millimeters, again, from here to here. Also, you notice I've got a little set screw here, and I'll show you just in a second how that works. I installed this set screw right here. This is the lower mast, this is the upper mast. So now when you slide the lower mast onto the upper mast, or slide the upper mast into the lower mast, this set screw positions them so that when you set up the rig, all the fittings that you have, say for the boom vang, the gooseneck, the fitting at the top of the mast, they all line up. And so now the mast, the lower section and the upper section, when you put them together, because of this little set screw, they'll be properly oriented. So as I move on with the mast, I'm going to be painting it. I'm going to be using a two-part epoxy, and I'm hoping to get a really, really nice finish. Super durable, super high gloss. I'll cover that in future episodes. Painting the mast isn't all that exciting, except it's going to look really good. So between getting the mast straight and putting it together, I'm pretty much finished with this section. Just another little bite out of the elephant. I hope you've enjoyed watching, and I hope just a few of these little things can help you with your build. So once again, thanks for watching, and so long for now.